In this video, what we're going to do is we're going to take this function, f of x equals 1 over x minus 4 plus 2, which I've graphed over here, and we're going to define the domain and the range. We'll start with the domain. And to do this, the first thing is we'll think algebraically. That is, we will look at the function and we will say, hey, what can I plug into the function? What can I not plug into the function? Well, obviously, there's some nice things we can plug into the function. For example, we can find f of 0. That would be 1 over 0 minus 4 plus 2. And that works out to be 1.75, and we can even see that on the graph. Yay! We plug in 0, we get a value. We plug in 2, we get a value. Alright, what can we not plug in? Well, if you notice something, we've got a problem with 4. If we try to plug in 4, f of 4 would be 1 over 4 minus 4 plus 2. And we'd have a 1 over 0 situation. Uh-oh, this is bad. Any other number besides 4 is going to be okay. But plugging in 4 is bad. So I'll often talk about domain with a capital D. Our domain is the set of x that is not equal to 4. 4 is the one number we cannot plug into this function. Now we can also think about this graphically. Graphically, what you're doing when you have a graph of a function is you're saying, alright, if I take points and go down to the x-axis, what gets covered? We'll go over here as well. And you see we cover a lot of points. And you may even see this if you did a plotted this on your graphing calculator. There's kind of this line. Ooh, that's not a great line, but there should be a vertical asymptote at 4. In other words, what happens is on the x-axis we cover lots of points if we squash things down. But we don't cover 4. We cover lots of points over there if we squash things down, but we don't cover 4. So graphically, what we say is that, again, our domain is a set of x such that x is not equal to 4. And the idea is you take your graph and you smush it down onto the input line, the horizontal axis, and you see what gets covered. Alright, so that's two ways of finding domain, algebraically and graphically. Let's talk about range. Now, when we do range, I'll tell you right now that we're only going to talk about range graphically. There are some ways to do it algebraically, but we don't emphasize that in this class. And I think what I'll do is I'll put down another copy of our graph so it's nice and clear. With range, what we're doing is we are thinking about what outputs we get. So for example, we've already talked about one output. We've got an output up here at 1.75. But the way we think about it is we think about going to the function and saying, hey, what y values do I get out? What outputs do I get out? What outputs do I get out? And so notice that in this case, what we're doing is we're always moving over, left or right, as opposed to up or down. And you just might notice that we have a line that we appear to approach at height 2, but not touch. We get closer and closer to that line, but we never actually approach that line. We never actually touch that line, I should say, excuse me. So if we were thinking about range values for this function, and I'll use a capital R for range, we would say that we'd be getting all the y values that are not equal to 2, because we appear to approach values of 2, but but we never actually hit a value of 2 with our function. Notice the difference here. With domain, we're going up and down. We're trying to figure out what points on the x-axis we hit. With range, we're going left and right. What points on the y-axis that we hit. Alright, this is a good introduction to domain and range, but please, if you got questions about this, ask me in class.